Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the four lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table, and we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40, and we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80, and the frequency is how high it is, which is 10. The next midpoint is here, so that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally, the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160. So that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get an integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together. 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds. So when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. We can keep this as an interior angle, but it's actually sometimes easier to convert it to an exterior angle. And what you might know is that the sum of interior and exterior angles is going to be 180, because they will always form a straight line. So to find the exterior angle, all we need to do is 180 take away the 170, and that means it will be 10 degrees. So we've already done a different formula for exterior angle, which is 360 divided by n. And something we can do is we can just swap these two things around. And so we can make the formula that n equals 360 divided by the exterior angle. So 360 divided by the exterior angle, well, we know that the exterior angle is 10, therefore n is 360 divided by 10, which would be 36. To find the gradient, we use a simple formula, which is m equals the second y-coordinate take away the first y-coordinate over the second x-coordinate take away the first x-coordinate. So our second y-coordinate is 17, so it's going to be 17 take away the first one, which is 14, over the second x-coordinate, which is 60, take away the first one, which is 45. So that's going to be 3 over 15, and then cancel that down, will be 1 over 5. So our gradient is 1/5. To find an error interval, what we need to do is find the smallest and largest that a number can be. So I start by just drawing a quick number line, and we put our number in the middle, which is 89.6. Now we're looking to the nearest tenth, so what I'm going to do is I'm going to write down the next number down and the next number up in tenths. So the next number down would be 89.5, the next number up would be 89.7. Now the bounds, the upper and lower bound, the maximum and minimum number it could be before rounding, are going to be at the halfway points. So here and here. And so all we need to do is work out what those numbers are. So halfway between 89.5 and 89.6 is 89.55, and halfway between 89.6 and 89.7 is 89.65. So those are going to be our lower and upper bounds. But how do we show it as an error interval? Well, we put t in the middle because it tells us that t is representing the time, and we show it with inequalities. Now, the number can be 89.55, but it can't be 89.65 because that would round to 89.7. So we say everything that's less than but not equal to. First thing we need to do is work out the volume of this prism, and it's a trapezium-based prism. So the volume will be the area of the cross-section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now A and B are the two parallel sides, which will be this one and this one. And then the H is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10, and that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, for this, will be the volume gained over time. Now, with this question though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves. So we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus x and minus x, that's be a minus x. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know x is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So A plus B minus C will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9, and so that will be minus 18. So our column vector will become 18 minus 18. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. To find the area of a rectangle, all we do is the length times the width. So the length, doesn't matter which way around we do this, is say 2.4, and the width is 9.8. But it says it wants to find the minimum area. So to find the minimum area, what we want to do is find the minimum length and the minimum width. So it says it's rounded to the nearest tenth of a centimetre. So we can do some quick lines, some quick number lines here to find what the minimum would be for both of these. So for 2.4, the next number down would be 2.3, and we just find the halfway point. Halfway point would be 2.35, and similarly with 9.8, next one down would be 9.7, the halfway point would be 9.75. So we're going to find the length, which is 2.35, times it by the width, which is 9.75. Let's just do that a bit nicer. And that gives us the answer of 22.9125. So it'd be 22.9125 centimeters squared. We're first of all going to find the multiplier for this question. So we start off with 100%. It's a compound interest of 7.2%, so we can add 7.2% on, and that will give us 107.2%. Convert that to a decimal or a multiplier by dividing it by 100. That would be 1.072. So that's our multiplier there. Okay, so we know that every time we times something by 1.072, it's going to increase by 7.2%. So we're going to just make up a number. So let's say £100. It doesn't actually matter which number you pick. And what I'm going to do is I'm going to type in £100 into my calculator, and then I'm going to type the equals button. I'm just going to press the equals button, okay, which sounds a bit weird, but I'm going to type in 100 into the calculator, press equals. Then what I'm going to do is I'm going to times the answer, so I'm going to press the ANS button, times 1.072. Okay, so I'm going to talk you through that again. So we're going to put the 100 into our calculator, then press the equals button, and then type in answer times 1.072. Now, every time we then press the equals button, we're going to increase the number by 7.2%. So we press it once and we get 107.2. Press it again, 114.9. Again, 123.1, etc., etc. And you keep going. Now we're looking to see when the money is doubled. So we're counting how many times we've got to press the equals button until it doubles the money. So after 9 years, after 9 presses of the equals button, we get 186.9, and then press it again and we get 200.4. So it's going to be 10 years to double the money. So we're going to write out the formula again just to give us a bit of space. And so we've got 4w over 7 plus 91. So going to first of all put our lines in because we're asked to make w the subject. So we need to remove everything that is in our way. Well, this plus 91 is the first thing we get rid of. So what's the inverse of plus 91? Well, subtract 91. So we're going to subtract 91 from both sides. So we've got a take away 91 equals 4w over 7. Next, we've got this 4w that's trapped in this fraction. So we've got to get rid of this fraction here. So that is over 7 or divided by 7. How do we get rid of that? Well, we times both sides by 7 because divide, the opposite or the inverse of divide is times. So we're going to end up with 7 times a minus 91. So it's timesing the whole thing equals 4w. The last thing we want to do is get rid of this 4 here. Well, that's a times 4, so how do we get rid of it? Well, the opposite of times 4 is divided by 4. So we're going to divide both sides by 4. So 7 brackets a minus 91 over 4 equals w. Now, some of you might be thinking that we haven't finished the question because we've got a bracket still. But actually, the bracket is absolutely fine to leave. We don't need to expand it. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively, k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9. And all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. To answer this question, we're going to do something a bit weird on the calculator. And this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution. And you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309, equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. A normal sine graph would go up to 1 at 90, then 0 at 180, then down to -1 at 270, then back up to 0 at 360, and it will start at 0, 0. But when you've got a 2 inside the function, so we've got 2x, you'd think it would double the x-coordinates. It doesn't. It just halves the x-coordinates. It always does the opposite, the reciprocal of what you think. So a 2 would halve it, a 3 would divide it by 3, and similarly a half would double it. So looking at this first x-coordinate, we've got it at 91. Well, that will now be at 45, 1. This next one here is at 180, it crosses the x-axis. It will now cross the x-axis at 90. Get to -1 at 270, halve that, and we're just halving each of the points. And so you get instead of 1 period, which is between 0 and 360, you actually now get 2. So it goes, and make sure you've got nice U shapes here. Goes up to 1, U shape at the bottom. That's 1 period. Now that normally is between 0 and 360, but here we've got enough space now to actually have a second period. I'm going to start off this question by finding length BD, and we do that by doing a little right angle triangle down here, and let's draw that right angle triangle out. Okay, so we've got a length of 4 on ED, length of 3 on BE, and we're looking for length BD. So we're going to use Pythagoras. So we've got BD squared equals BE squared plus ED squared. Get our little tram lines in. Okay, so BE is 3, so it's going to be 3 squared plus 4 squared, and that's going to equal 25. Square root both sides, and we've got BD is equal to square root of 25, which is just 5. Okay, we need to now work out what MD is, because we're looking for length AM. So MD is actually just going to be half of BD. So it's going to be half of 5, which is just going to be 2.5. The reason for that is that all of the lengths AB, AC, AD, AE, all of them are the same, so therefore point A will be exactly at the midpoint or above the midpoint of the square, so M is obviously at the midpoint. Okay, next we're going to draw in another right angle triangle. It doesn't actually matter which side we take. We're just going to take this side because we've worked out what MD is. And let's draw that out down here. Okay, so we've got the length of 5 here. We know the bottom bit is 2.5, and we're looking for the length AM. So another bit of Pythagoras here. So AM squared is going to equal, and we're looking for AM, yep. AM squared is going to equal AD squared, take away MD squared, and AD squared is going to be 5 squared minus 2.5 squared, which is going to equal 18.75. Then we'll square root both sides. I haven't put my tram lines in. Let's get those in as well. Make sure it's all neat and tidy. So we've got AM is equal to 4.330, and because it says 2 decimal places, we want to write down the answer 4.33 centimetres. You can complete a unique version of this paper by going to our onmaths site, OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.